This is going to be our video recording for the lecture, and one of the things that I wanted to first go back through is a few of the things that we covered in class. So let's go ahead and start a new script. Let me go ahead and open it up and scale it up a little bit. And so we did some basic plotting in class, where we started with clear and CLC. Remember, in class we covered a new formatting command, which was close all. And then we started with some X data that was like 1 to 5, and we had some Y data, which was purely random, but in some classes it could have been something like 2, 5, 4, 3, 7. As long as we have the same number of data points in X and Y, we're going to be fine. So we plotted X comma Y, and eventually we got this. Oh, let's wait for it. There we go. So we realized that this was connecting all of the points with lines. There's actually 1, 2, 3, 4, and 5. You can see them sort of turn into little circles when I hover my mouse over. We then covered that we wanted to plot discrete data points, so we came over here and we typed help space plot, and with help plot we found our 3 columns that contained the colors, the markers, and the line types. So then we could come back and we could say something like, alright, so now let's make these circles, rerun it. Now we have all of our discrete data points, as in they show up as points, no longer lines. 1, 2, 3, 4, 5. And then we could have something like an xlabel. In one class we called this time. And time was measured in, I don't know, we'll call it hours. Okay, and then we had a ylabel. And we could call this something like velocity. V in, let's go with miles per hour, just so that we have a unit consistency to it. We can have a title, and for our title we can say, what are we dealing with? 2, 5, 4? Yeah, sure. Let's go with 5K walkers speeds, and we need that to be possessive, so let's add a second apostrophe. We rerun it, and now we have our title, our xlabel, and our ylabel. We need the grid as well. And then the last thing that we covered, so now we have a grid here, which helps our reader traverse with their eyes left and right and up and down. It just makes this easier to read. The last thing that we wanted was we wanted to sort of put some limits on our axis so that we didn't have any data points slammed up against the left or the bottom or the right or the top. So we'll go from 0 to 8 in the Y, but from X we'll go from 0 to 6. So we'll do axis 0 to 6 as in my xmin and xmax, and 0 to 10 for my ymin and my ymax. So then we run this and bam, we've got 1, 2, 3, 4, 5. All of these points appear in that field, and now we have a properly formatted plot. We covered different ways to do things like plotting multiple data sets. So then if we turned this into runner 1, and we would then need to copy and paste right here for runner 1. And then if we had runners 2, 3, and 4, if we just sort of 2, 3, and 4. And by the way, this lesson is going to go kind of quick because this is a recording, so you're going to be able to back up and rewind and rewatch if you miss something. So let's just come up with 5 random speeds for this runner. We'll start with, let's go with 6 miles per hour, then 4, then 3, then 3, then 2. Let's say this person started off a little bit slower and then sped up. So 4, 5, 7, 8, and then 5 is how they finished. And then we'll say some of them were running and some were walking. So we'll say runners / walkers speeds. Let's see, now we need runner 4. Runner 4 we'll say just, was sort of leisurely. So 3, 4, 4, 3, 2. And now what we're going to need to do is, now we're only plotting runner 1. So let's go ahead and copy this line, come down below, paste, paste, and paste, and then we'll plot runner 2, runner 3, and runner 4. Now, since we have 4 different data sets, we don't want them all to appear as circles. So let's do 1 as a circle, 1 as a square, 1 as an upward facing triangle, so we'll use a caret, and 1 as I don't know, P for pentagram. You guys tend to love pentagrams. We'll run this, and we see that all we have at the end is the pentagrams. They are blue. I mentioned in 2 of the classes that blue is the first color that MATLAB uses to plot. It goes blue, then green, then red. So we know that we're getting this one, but again, one of the points that we hit on in class was if we didn't tell MATLAB to hold any information, then it was going to scrap everything that had been plotted before. So here, after I execute my first plot command, I'm going to execute a hold command. And we'll run this, and bam, now I have all four data sets, but since I have 4 data sets, I'm actually missing one extra thing. That's my legend. Let me also mention that all of this information, xlabels, ylabels, titles, grids, legends, axis commands to restrict the size of the visual domain for the plot, those don't have to be in any particular order. You can do a title, then a label, then a grid, then an axis, or you can do the axis, then the labels, then the grid, then the titles. So these can occur in any order that you'd like. So, but we do have 4 data sets, x in runner 1, x in runner 2, x in runner 3, x in runner 4, so now we need 4 strings. We'll say participant, since some can be runners and some can be walkers. And again, I want to be lazy but in a good way, so I'm going to copy and, oops, I think I did something wrong there. Okay, I'm not really used to copy and pasting by right-clicking, so I'm going to Control-C, Control-V, V, V, and then we'll close it all out. Let me go ahead and make this a little wider so you can see the whole thing. So I've got my legend, participant 1, and then participant 2, and then participant 3, and then participant 4. So now when I run this, I end up with a legend that explains all of that information. One extra thing, I did cover this with one class but not the others, that we can do the whole ... return, and then comma, ... and then return, and then comma, ... and then return. And what we did in that class was we actually, after participant 4, did comma, ... and then return, and then we changed the location of the legend. So because it was sort of hovering over this data point, and we're possibly covering this one up, we wanted to make it so that we didn't have to manually move it every time we ran this plot. So to that end, by default, MATLAB places the legend up in the top right, but we want it in the top left. And as far as locations go in MATLAB parlance, those are basically governed by as cardinal directions. So north, south, east, north, south, east, west, and then we have northeast, southeast, southwest, and then this would be northwest. So we can go ahead and put in northwest. And now when I plot this, the legend will appear up in the top right each time I run it. I don't have to manually move it. So that was something that I covered in one class but not the others. The next thing that we covered was how to plot continuous data sets. So for that, we also covered things like designating colors. So if the first one was red, and the second one was blue, and the third one was green, and the last one was black. But we also covered things like line types. So let's make the first one solid, the next one dashed, then we got a dash dot, and then the last one I guess we'll just make dotted. So now, once we have multiple data sets that we want the user to be able to track easily, because we have points that are over one another, so it's a little bit difficult to see how all of this moves from point 1 to 2 to point 3 to point 4 to point 5. So there we go. Adding lines visually helped us out. But the next thing that we covered was we talked about how, and I guess I can make this taller because the plot will come up each time. Let's actually move it over there. Then we added a new section, and we were basically plotting continuous functions. Okay, so for continuous functions, we again started with clear, close all, CLC. There's an extra L there for you. And we can talk about plotting continuous functions using trigonometric functions. There we go, trig functions. So for the trig functions, we've got, our x data, which actually we called our angles. So we'll say angles. Started at 0 and went to 2 pi because we did this in radians. We then said that, I guess, curve 1 is the sine of x. And then let's go ahead and copy that. Paste, paste, and paste. Because this time we're going to have curve 2, and then curve 3, and curve 4. All right, so curve 1 is the sine of x. Curve 2 we'll call the cosine of x. Curve 3 we'll call the sine of 2x. Curve 4 we'll call the cosine of 2x. You know what, let's actually do a few more. Let's do 6 or 5 and 6. Actually, we'll just do copy and paste. That way we can do 5 and 6. And for 5 and 6, we're not going to do the cosine of 2x. We're going to do 2 times the the sine of x, sorry, not cosine, and then 2 times the cosine of x. So now we have 6 curves. Now here's the thing, we got to plot everything, and we're gonna plot angles. Copy that and paste, comma curve 1, copy that and paste, and then dot dot dot, and then we can copy this part again, paste, return, paste, return, paste, return, paste. So I've got curve 1, curve 2, curve 3, curve 4, curve 5, and I think I need one more. So let's go ahead and bang that one out. So curve 6. All right. So now I don't need to use a hold. This was the second way that we talked about plotting multiple data sets. Here, I executed the plot function, and then I executed a hold. Here I'm going to use one plot function, and since I put in my first set, my second set, my third set, my fourth set. Now in class, we added modifiers in the form of a string right here to do the same thing we did here, where we had line types, markers, and colors. I'm just going to go ahead and run this and see what I get, because again, we're going to hit the, oh, what do we got? X. Oh yeah, sorry. This should be angles, 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 and angles. So now we're going to run it, and we get all of those jagged lines. Now we talked about that in class. Okay, that's because we started with 0, we ended at 2 pi. MATLAB by default, when you give it a start and an end for a matrix, steps by 1. So each of the counting integers. And over here you can see angles houses 1, 2, or 0, 1, 2, 3, 4, 5, and 6. Now that's what led to these being jagged lines. We want them to be curved lines, right? Because most of the time when you see trigonometric functions, they're in the form of curved lines. So the way we handled that in class is I didn't go start and ending value. I went start stepping value, which we could say is like 0.02, and then colon ending value. So 0, which is my start, colon, my step, 0.02, colon, my end, 2 pi. Now when I run this, I get 6 very nice curved lines. Now they all go up to 2 pi, but again, MATLAB loves to step things by integers, so that's why 7 is the end of my window here. So again, at the end of all of this, we're going to say axis. I liked my y, that my y started at -2 and ended at 2. We could probably actually bump that out a little bit, so let's go ahead and say for x, we're going to go from 0 to 2 pi, and for y, we're going to go from -2.5 to positive 2.5. Okay, well, that's not a point, so there we go. So let's close out the array and then close out the parentheses. Again, remember that the array is encapsulated with brackets, and the parentheses are everything that we're going to pass the function. So the function is axis. So then we're going to go ahead and run this again. And now I go from -2.5 to 2.5, again, because I don't want data slammed up against the top or the bottom of my graph. And we've ended on the right-hand side, 2 pi. Now we also covered in this class that we had something that we wanted to initiate a hold for, because then we wanted to plot an x-axis, right? So the values for the x-axis are x equals 0 to x equals 2 pi. And then for that, I'll need corresponding y values for the ordered pairs, and the y values for the x-axis are 0 and 0. So let's close that out. Now our x-axis is usually always black, so we're just going to add it as a k. And now when I run this, I get a nice black x-axis. We need the rest of our formatting, right? So we have to have a grid on. We need an xlabel. In class, we covered that the xlabel was usually the angle, and then it was a theta was the symbol, and the unit is usually in like degrees or radians. In this case, it's going to be in radians because we said 2 pi. Let's get rid of the capital N. And then here for the ylabel, we needed amplitude. And for amplitude, the variable is A, and then it was some unit of length, right? So we're just going to make this one up on the fly and say it's millimeters. We also needed a title for this whole thing. This is going to be a comparison of various trig functions. Okay, because really what this does is it helps us look at what are the base trig functions, and then what are the base trig functions when we double the angle, and what are the base trig functions when we double the magnitude of the outcome of passing an angle to one of our base trig functions. So now I got a grid, an xlabel, a ylabel, and a title. I'm going to run it, see if all of this flushes. Oh, I'm doing my capitalized second letter again, so comparison. So we'll rerun it. Comparison, we've got angle, theta, and radians. Now in class, we didn't have a theta here. We actually just, we had the symbol theta, and the way we did that was right before the word theta, I'm going to add a slash. And this was just like when we used the fprintf function, and we use slash in to get ourselves to a new line. Here we're using slash theta to get a character, because I know this is a little beyond where we are for this class, but this initiates an interpreter, and then we use this character keystroke or ASCII value or whatever is encoded. So that's why when we run this, we get a nice theta symbol. Now the last thing that we covered was we went from 0 to 2 pi and we sort of changed this axis. And the way we did that was I showed you guys that I'm actually okay with you going out to the internet. So let's actually go back. Okay, and let's cover MATLAB. And we want to change the x-axis to pi over 2, and I think that's enough. We'll go ahead and just click on the first one. We'll open this up a little bit. All right, so here we have a question that was asked on the MathWorks forum, and we have somebody that answered. And when he answered, he said, look, okay, so you want to change all of this. You want to set, and then set is the name of the function. We're going to establish something. And what we do here is it says get current axis. The property of the current axis that we want to change is the xtick marks. You want to start at 0, we want to end at 2 pi, and we want to jump by pi over 2 each time. Okay, so let's execute that one first. Now I told you guys I'm okay with you getting all of this and using it, just as long as, so let's go ahead and paste this in, as long as you give credit to where it came from. And I also told you that if you submit any homework, so I'm going to go ahead and copy this address. We're going to paste it in. If you use anything like this in the code you submit for a homework assignment, then you're going to have to be able to describe what's being done in this. So if I call you into my office and I ask you to explain the set function, or what does GCA mean, or what are the other properties here besides xtick, or what this does, then I expect you to be able to explain how all of this works. Otherwise, you're going to get a 0 on your homework. So I'm actually going to just run this because I want to see the difference. In class, we copied both at the same time. So let's just run the first. So now instead of on my x-axis it going from 0 to 1 and 2 and 3, 4, 5, 6, now I have the actual decimal values for pi over 2, pi, 3 pi over 2, and 2 pi. Well, that's cool. Let's change this to pi over 4. Let's see what we get. Now we get multiple values, right? So that's cool. So I'm actually going to leave it like this. But before, actually, we're going to drive towards that. So let's change it back to pi over 2. We'll copy the second line. Here we go. And we'll come down here and we'll paste it in. And now when I run it, I don't have the decimal values. I actually have pi over 2, pi, 3 pi over 2, and 2 pi. Now the last thing we did in class is we actually came in before the pi's and we added that slash again. And by adding that slash, and I also got rid of these because I don't like the stars. Now the word pi is replaced with a pi symbol. But I'd actually like to see more grid lines here because in class we ended up with this. But I'd like to see a few more. So here I'm going to change this, not pi over 2, but pi over 4. Now, because this is pi over 4, I'm going to have 0, then pi over 4. So right here, I'm going to have to start adding some stuff in, right? So I go 0 to a pi over 4, comma, and then I'll have a pi over 2. There we go. And then after a pi over 2, I'm going to have a 3 pi over 4. Okay, then I have a pi. Then I'm going to have 5 pi over 4, comma, and then let's see. So we got pi over 4. Let's go ahead and, yeah, that's the right slash. Let's do it this way. This is going to be 2 pi over 4. This way we can keep it straight because this is going to get long fast. 3 pi over 4. And then 4 pi over 4. This is just a trick to help you keep it straight. 5 pi over 4, then 6 pi over 4. And we'll go to the next line. And then we're going to have 7 pi over 4. And then our last one, yeah, there we go, is going to be 8 slash pi divided by 4. And then we'll close it out. So now, let's see if this works, because I have to have the right number of strings. So pi over 4, 2 pi, 3 pi, 4 pi, 5. Oh, for my 5, I didn't add my slash. 6 pi, 7 pi, 8 pi. So I know for my 5, I got to add my slash. And then we can start reducing some of the fractions, right? So 2 pi over 4 is just going to become pi over 2. And then I've got 3 pi over 4. 4 pi over 4 is just pi. Then I have 5 pi over 4. 6 pi over 4 is 3 pi over 2. Then I have 7 pi over 4, and then 8 pi over 4 is simply just 2 pi. So we'll get rid of that. Now we run it, and we have everything properly formatted. Now I did that because I wanted more grid lines here, and I couldn't just add more grid lines if I didn't have all of these descriptors, or all these tick labels, as it's called. So I changed the tick marks, then I added labels to all of those. And so now I have a pretty nicely formatted comparison of all the trigonometric functions, except I don't know which one is which because I forgot my legend. So let's come back. Let's say legend. For the first one, we're going to say y equals the sine of theta, or a equals the sine of theta, actually. Because according to our variable notations, that's what we had. And then, oops, sorry, dot, 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 not apostrophe, apostrophe, apostrophe. For my second one, I have a equals the cosine of theta, dot, dot, dot. Now for my next one, I'm going to copy those two because we're going to come down and go bang, bang. This one will have to come down again. Now I have sine, cosine, sine, cosine, sine, cosine. So I did the sine of 2 times theta and the cosine of 2 times theta. And then I had 2 times the sine of theta and 2 times the cosine of theta. So look, again, I know this is going kind of fast, but again, it is a video and you can pause and rewind. Also, I've been doing this for a long time, so I can bang out this code a whole lot quicker than you guys can. The issue is, for you, you need to practice. So you're going to go through and make this example while you're watching this video, but you need to make others. So that's kind of going to be the exercise associated with this lecture that I discussed in class. Now I've created a legend. Excuse me, I've created a legend. Let me go ahead and run this. We'll see what pops up, and there we go. Now we've got a legend. Now that legend is sort of covering up a little bit of our data, so let's move it around, see if we can get it to where it won't cover up some of our data. That kind of works. It's not really getting there, so let's do this. Let's make the window a little bit taller. Now the legend being right there doesn't cover up any of my data. You want it to look nicer, it could probably be down at the bottom left. And there you go, but this fits too. And so now I have that whole thing, and I showed you that you can come up to edit, copy figure, then you can paste this into a Word document. But here we have where we've defined some arrays, we've plotted them, we initiated a hold so that we could then plot an x-axis right here. We changed our axis limits from 0 to 2 pi on the x, from negative 2.5 to positive 2.5 on the y. We added a grid, we added an x label, a y label, and a title, and then we set our x-axis labels by first changing the tick marks from 0 to 2 pi by pi over 4, and then we changed the xtick, those were the ticks. Then we checked the labels. And for that, we needed a cell array, which we've talked about in class. We've talked about it once when we used the input dialog box. For more information on cell arrays, we can talk about it in class. You guys can look it up online. Plenty of information, but this basically enables us to save the first position of an array with a string of some known length, the second position of a cell array with a second string of some unknown length, and those lengths don't have to be the same. If you save an array of strings, they all have to be the same length. If you save a cell array, not an array, save a cell array, not all those strings have to be the same length, but you can then reference them by their position, just like a normal array, where you have a first number and a second number, a third. None of those numbers have to be the same length, but they all fit into a numeric array. We sort of talked about that in class. So the last thing that I want to cover in this is something that some of the classes we didn't really get a chance to get too deep into, and this is plotting multiple curves in different we'll say plotting spaces in the same figure window. We'll say same figure. Okay, so in previous examples we had one figure window. This is the figure. See, it says figure 1. And in this plotting space we just plotted 6 curves. But let's say I want to see a comparison of all of them, but not all at the same time in the same space. So for that we are going to say clear, close all, and CLC. And again, I'm doing all that. Let's just go ahead and come up here. Let's copy all of this. Okay, because that's really what we're after. Now we have all of our data sets that we need. And now we're going to plot everything. So let's just talk about plotting the first 3 first. Okay, so let's come here to my plot. We'll get all 3. We'll say copy. We'll come down here. We're going to want to sort of change this because we're going to want to plot all of these independently. So let's get rid of all of the exit information. All right, and then we'll add a plot command to each one. So we'll copy this, and we'll sort of paste and paste. All right, and I'm not going to initiate a hold this time because I told you this time I want all of them in their own spaces. So to do that, I'm going to use something called subplot. Okay, now for the subplot, you're just going to have to go with me for a minute, but the help information pops up. It says m, n, p. M is the number of rows in my subplot. N is the number of columns in my subplot, and P is the position. So the position sets the active location in the subplot, which is going to make more sense in a minute. So let me just 311, and then I'm going to copy this and paste, except I'm going to change the second one to 312 and the third one to 313. So I have 311, 312, and 313. So here I have first position, second position, and third position. Now when I run this, I don't have one figure window with one plotting space with 6 different curves, or 3 different curves in this for this example. Now I have one figure window with 3 plotting spaces, each having 1 curve in them. So now I can start taking a look at, okay, cool, so now I have 3 different plotting spaces. Now I can see each curve independently. So now I don't have multiple curves, I won't need a legend. I will need all of my formatting information for each one, so we'll actually come up and we'll do this. So I wanted a hold, okay, and then my axis, my grid, my X label, my Y label, and then we actually did all of this, but we'll cover all that in a minute. So let's copy this, and below my first plot, I'm going to paste this. All right, so now I have all of my formatting information right here associated with my first plot. I'm going to run it, and you'll see that my first plot is now properly formatted. Now it goes to 2.5 to 2.5, I'm sorry, negative 2.5 to 2.5. This is a sine curve, so we can probably now change that on an independent basis. This is going to be my axis. Let's go from 0, or I'm sorry, negative. Let's just make it 1.5 to 1.5. We'll run it. That way it doesn't seem so thin. There we go. And actually, you know, we could probably just go 1 to 1. So let's just do that. And it will hit the top and the bottom, but it's a sine curve. We're cool. It's fine. That's okay with us. If we make it a little bit taller, then we can see it all. So now what you'll notice is I have all my formatting information right here on my first plot, but not my second or third. And the reason is now I need all of my formatting information copied and pasted for each plot. And once I do that and I run it, now I have all of my formatting information for each plot. Now the thing is, the title is comparison of various trig functions. In a case like this, again, the picture's worth 1,000 words, right? That's why we're plotting data. So we need all of this to be accurate and for it to make sense to a reader. So we're going to change comparison of various trig values. This one is going to be, we're going to go up and look at our legend. So here I have A equals sine theta. I'm going to copy that. That's going to be the title of my first plot. Okay, my second plot is going to be A equals the cosine of theta. Okay, my third one is going to be the sine, A equals the sine of 2 theta. So let me copy that. And we'll paste it. And then this is where we're going to sort of take a pause for a minute. So now I have a grid. I have proper titles. I have labels on the X and Y axis. I haven't done all of the tricks for my X-axis ticks and my X-axis tick labels yet. We can add that in a minute, but it just sort of clouds the issue and adds too many lines, so I'm going to leave that off for a second. Because now I want the other 2. I'm sorry, other 3. So I had the sine of theta, the cosine of theta, the sine of 2 theta, the cosine of 2 theta, 2 times the sine of theta, and 2 times the cosine of theta. And I wanted to see it all together. So the way I would probably do that is I would put all of the sine values or sine curves in one column and all the cosine curves in another column. Now you could do that in several different ways. So let's pretend we want a column of sine curves and a column of cosine curves. All right, to that end, here I have, I told you, an array of plots. So subplot has 1, 2, 3 rows and 1 column. That's 3 rows, 1 column, 3 rows, 1 column, and 3 rows, 1 column. Now if I need 2 columns, then this has to change to a 2. So we're going to go 3, 2, or 3, 2, 1, 3, 2, 2, and 3, 2, 3. And this actually serves as a helpful example because I want you to see the positions in the subplot. So the subplot actually views this as position 1, this is position 2, this is position 3, this is position 4, position 5, and position 6. So it works its way across rows and then down. So column 1 in a row, column 2 in a row, column 1 in the second row, column 2 in the second row, column 1 in the third, and column 1 in the fourth. And we have 6 because 3 times 2 gives us 6 positions. Now luckily I have sine and cosine, and then sine of 2 theta, and then I guess I could say the cosine of 2 theta. So this is all kind of working out, right? So now what we would do is we would come in and say, all right, so now let me copy this block, the whole block. I'm going to paste it right down below because here I have 3, 2, and I want to work out a position 4 this time, right? And I want to plot curve 4. And it's not the sine of 2 theta, this is the cosine of 2 theta, because if we go back up to our legend, 1, 2, 3, 4, this is my string to describe what that data set is. So now I have the cosine of 2 theta. So now I run this and I get my 4th position out of the whole thing. Oops. Sorry, what we're doing. Let's run this section. There we go. So I run this section, and this is what I get. Sine, cosine, sine of 2 theta, cosine of 2 theta. So all right, I can round off this whole thing by saying I want these last 2 blocks. Okay, let's copy the last 2 blocks. We'll paste them down below, and we'll work on these. This is going to be my 5th position, okay, and this will be my 6th position, again, based on 1, 2, 3, 4, 5, 6. Now, here I'm going to plot curve 5, and here I'm going to plot curve 6. I'm going to come back up to my legend because I got a lot to keep straight here now, right? So I'm going to copy my string from my 5th data set from my legend, and I'm going to replace the title in my 5th plot with that value, and then I'm going to come up to my legend and take the 6th one, copy it, and then we'll come down and replace the string in the title with the string from the 6th location in our legend. And now I have an array of plots. Okay, I'm gonna make it bigger so that I can take a look at all this. I know what sine looks like, I know what cosine looks like, but now I know what doubling the angle looks like, and now I know what doubling the magnitude looks like. Now here, these don't really work, right? Because when I double the magnitude, here at pi over 2, we have a magnitude of 1. Here at pi over 2, we have a magnitude of 2, and we can't really see it. Okay, so I'm sorry, here at pi over 2. Sorry, this will be pi over 4. Here at pi over 2, okay, we have a magnitude of 1. Here at pi over 2, we'd have a magnitude of 2. So I got to come back to my code. And for 5 and 6, since we doubled the magnitude, this isn't going to go from -1 to 1. It's going to go from -2 to 2. And then this one's going to go from -2 to 2. Okay, and now we can run it, and now you see. Now here's the deal, okay? The subplot can be as big as you want, so let's play around with this. Let's, instead of 3, 2, let's say 3, 3. Okay, so 3 and 3, and I actually don't like doing all that, so let's just copy it, and we'll paste it, and we'll paste it, and we'll paste it, we'll paste it, and we'll paste it. Let's make sure 1, 2, or let's say 6, 5, 4, 3, 2, 1. Good, it's 3, 3, 1, 3, 3, 2. So I was just checking. So let me run this. Now we have 3 by 3, right? So now we've got sine, cosine, and now our sine is all messed up, right? Because we had position 1, position 2, position 3. So now I don't have clean columns of information, nor do I have clean rows of information. But if I wanted to put all my sine stuff in the same row and all my cosine stuff in the same row, then what I could do is I could come back to my code and I could say, look, all right, here I'm plotting a sine. I want that in position 1. Here I'm plotting a cosine. Let's actually put that not in position 1, let's put it in position 4, right? Because position 4 is right here. Position 1, 2, 3, 4. So I want a row of cosine values. So my cosine stuff should be in position 4, position 5, and position 6. My sine should be in position 1, position 2, and position 3. So let me sort of put that right here while we're working on this. All right, move this over. So I got the sine of 1 theta. I've got the cosine of 1 theta, so 1 and 4. All right, now I've got the sine of 2 theta. I want that in position 2. I got the cosine of 2 theta. I want that in position 5, right? 4, 5, and 6. And then I come down. Now I got the 2 times the sine of theta, so I want that in position 3. And I got 2 times the cosine of theta, so I want that actually in position 6. So that works out pretty well. Don't have to change that one. Now I have sine, 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 cosine, cosine, cosine. This houses my doubling the angle. This houses my doubling the magnitude. And that's important because then we could add a tangent right down below, right? Because for tangent, it's not the same domain. It's not 0 to 2 pi. It's pi over 2, or negative pi over 2 to pi over 2. So at that point, what we can do is we can come down. We can say, okay, let's come back up where we defined everything. I've got angles, right? Let's come down and say, let's say tan angles. Because for tan angles, we need negative pi over 2. Again, we'll go by 0.02s to pi over 2. And then we'll say curves. We'll say curve 7. Curve 7 is going to be the tangent of tan angles. Good Lord. Let's just copy. There we go. And then curve 8. Oh, we didn't do underscores. Curve 8 and curve 9. There we go. We'll just get out of the way. And then we'll say here, copy, paste, paste. So for the next one, we doubled the angle, so 2 times. And for the last one, we had 2 times the magnitude. So let's go ahead and throw this down below. So I've got curve 7, 8, and 9. I'm going to copy my last block. Actually, yeah, we'll just do it that way. We'll work down here a little bit, give us some space from what we just did. So now I want my 3-3 array, 3 rows, 3 columns, but now I want to work out of my 7th position. I want to plot curve 7. Curve 7 is actually not going to be anything multiplied by the magnitude, but it is going to be the tangent of theta. And now I want to change my axis and my plot for my x-axis, but we'll cover the x-axis in a minute. So this is going to be negative pi over 2 to a pi over 2. And I guess for the y min and max, let's go from like negative 20, I guess, to 20. That way we just add some zeros. Let's run it and see what we get. Okay, we got some problems. So back in my command window, let's take a look. Oh, they have to be the same length. So angles, because this needs to be tan angles. All right, when we plot things, they have to be the same size. So I'm going to copy it, because here I use tan angles to compute all my tangent values, so curve 7, 8, and 9. So you can see over here, curve 7 is 158 points, curve 8 is 158 points, curve 9 is 158 points. But my angles, that's 315 points, just like the previous data set. So now we're just going to come down. We're going to say, all right, instead of angles, I need tan angles. Cool. So now let me run it. We'll see what we have. All right, that looks okay. That looks okay. We got some stuff missing. I mean, you know, we need the x-axis to go all the way from negative to negative, so I can actually just take this and go, okay, let's take these two as my copy, and they're going to replace and become my new extents for my x-axis, because again, this is the x-axis plot, right? All right, so, oh, is that a dash? Let's run it, and now my black line for my x-axis goes all the way from the left all the way to the right on my plot. Now, we added an x-axis here because that helped frame our mental reference when we're looking at this picture. So in this one, we actually would want a y-axis too. So we initiated a hold. Let's go ahead and say, all right, let's do another plot. The x values for the y-axis are both 0. And my array for my y-axis, that's going to be negative 20 to 20, because that's what I was using to frame my window, as in the extents, my y min and y max. So let's run that and see what we get. There we go. So now we have another line. This time it's red. Remember I told you MATLAB does things in a weird order. Blue, then green, then red. Here it plotted this one in green, but then we changed it to black. Here it plotted this one in red. So this was blue, then green, then red. I want my axis to be black, so let's go ahead and just make it black again. And there we go. Now I've got an x-axis and a y-axis. They're both black. That's my normal tangent function. Up there it says tangent of theta. I'm not done, because now I need to copy this entire thing. We're going to paste it down below, because now I want to work out of the 8th position. I want to plot curve 8. Okay, and I'm just going to go ahead and paste down below again, because now I want to work out of my 9th position, and I want to plot curve 9. Now here's the thing. Curve 8 is going to be tangent times the doubling of the angle, and curve 9 is going to be twice the amplitude, so I'm going to change my titles accordingly. This isn't going to come out clean, I'm going to be honest with you, because when you double the angle or you double the amplitude, you get different numbers. Now, when you double the amplitude, you don't get different numbers. I'm sorry, I said when you double both of them, you get different numbers. This isn't drastically different, okay? So with this one, our extents, as in the frame of our window, those are fine. Here, we have negative pi over 2 to pi over 2, but since we doubled the angle, everything actually contracted, right? So here the wavelength is 0 to 2 pi. Here the wavelength is 0 to pi. So here, this isn't from negative pi over 2 to pi over 2 for one full wavelength. This is pi over 4 and negative pi over 4. So I'm actually going to come in. I don't actually care that it computed all of this, and we have these asymptotic limits framed in here. But I do care that it shows them. So you could leave it like this, or you could reframe it and have it go from negative pi over 4 to pi over 4. Here we didn't do from 0 to pi, so it really wouldn't matter. But then at the end, or in the end, what we have is we have a table of plots that help us discern the difference between doubling the angle and taking the sine, or doubling the amplitude after taking the sine. Same for cosine and same for tangent. So this is pretty much it for what I wanted to cover with plotting multiple discrete data sets, plotting multiple continuous data sets, and then walking you through the subplot. So there is going to be a piece of this where I'm going to ask you to change this code in order to do something. And then there is going to be a piece of this where there's going to be a homework associated with plotting in MATLAB. So be mindful of that on Blackboard. And I'm going to post this up to YouTube. So there will be a direct link on Blackboard, but there will also be a link on YouTube. So if this was helpful, The rest of the YouTube videos are pretty much just like this, so they don't go as fast for the most part, and they are a lot shorter because this is meant to be a lesson. So I hope this helped you, and if not, then take a look at what's in your book, take a look at what's online, see if that does help you. If not, I'll be back Monday and we can talk about it. Till then, good luck, and there will be another video posted for plotting in Excel. So again, till then, good luck.